This is the number input. The number input is all about state management. How do you store it? How do you update it? How do you keep it all in sync when multiple things are trying to change it? So we have these two buttons and an input. We also have an error field that will be touched on in the bonuses. But the task is, using the provided markup, create a working number input. Buttons should increment and decrement the number in the input field. Add a minimum maximum, handle direct inputs, and use or add informative error messages for the user. Okay. So the easiest way to start this is just to gather all of these things up. So we're going to go const add equals document dot query selector, and we're going to get that increment, right? Increment. Save ourselves some time by copy and pasting, just like this. So subtract is decrement, input, and error, okay? Once we have those captured, we can use them. So add event listener, because we're gonna have to update some stuff on click. So, whoops, what is going on there? It's going crazy. Yep. Almost forgot where I was there. Do something. We'll come back to this. So copy that, paste it down here, paste it down here. We have one for subtract. Is also going to be click, and input. Now input doesn't use a click, it actually uses input, just like this. So now we're ready. The question becomes, where do we put that state? Okay, we have a few different ways to do that. The very simplest way, and also the very worst way, would be to add it right to the global scope. So let state equal input.value, like this. Now if we go down to here, we can set that state. So state equals state plus 1. And we need to remember to update the input as well. So input.value equals state. If we hit that plus button, it should do something. We forgot a step. And what we've forgotten is that all inputs, even number inputs, are strings. Okay, so we need to make sure that we start with a string and then keep updating, or start with a number, sorry, force it to a number, and then keep updating with the number. So that one works. We can go down here, paste it in, make it a minus, and then down here, just like this, state is going to be whatever the input value is. I did that wrong. Why are you jumping around? Stop that. Hitting the wrong keys. There we go. So now we have plus, we have minus, and it all sort of works. Before going further, we should do something about the minimum 0 and maximum of 10, okay? And also direct input to the field. So right now, this is not a number field. It's just a regular input. And I can prove that. Right now I'm hitting the up and down arrows. And if you look, you'll see my cursor is jumping to the start and to the bottom, okay? Maybe if I add it here, you can see it jump a little bit better around the 50. It's not jumping into the middle of 50. That would be the left and right arrow keys, but up and down jump to the start and end. So this isn't a number input. If it was, the up and down keys would actually change the number. We can make that happen, not by adding up here, because remember, do not change the markup. But down here, we can add input.setAttribute, like this, and we set the type to number. And just doing that we get a number field. So now if I use those arrow keys, arrow keys, sorry, arrow keys are something different. Up and down works. We can also add in our minimum maximum right here. And the reason for doing that as a min and a max is that this will give us automatic error states. So this will allow the browser to work its own magic. We're letting the browser do the work. So now if I use the ups and downs, you'll see that it stops at 10, stops at 0. But if I hit that minus button, it still goes, but turns red, because over here in the CSS, I have an invalid pseudo class. And when this registers as invalid, it tells the browser, hey, I'm invalid. At which point you can hit that with CSS, and I changed the background to this tomato color, okay? Tomato. So we are getting automatic validation for free. And in fact, we can go further because it will give us a string error message also for free. We do that down here. We set our error.text content equal to something on the input. It is validation. If I can type validation message, okay? And now if this works, when I am all the way up here and I go one more, I get that error message automatically. If I go one less, it's not going to change. In fact, it's doing something very weird. That's so weird. We can look at that in a second, but let's go and add this down here and right here, so that if I go up, come on, there we go, up to 10, one more, one less. Why is it doing that? So I have some funky business going on. This one plus input value state plus minus. Oh, right, because it was still concatenating. So go down, we get an error message, go all the way back up, and one more, and it says must be less than 10. If we're down at 0, it says must be greater than 0, okay? So error messages are in. A lot of duplicate code. We're jumping around a little bit. Let's fix that really fast. Function update input. Update input, we're going to send it a value, and that input is going to be this error message. We can drop that right there. Ooh, clean it up a little. There we go. And we're going to put input value equal to val, okay? So from here, we can start to clean some things up. We definitely don't need this. We don't need this anymore. We don't need this down here. But every time we use input value, we're just going to send it to update input of state, okay? Grab that down here, put it here, even right here, why not? Just to be sure. That way we get those really nice error messages. Technically, we've already set the input, but setting it to the exact same value isn't going to hurt anything. So make sure that our error messages are always being cleared out. Cool? Cool. Back to state management. This is not a good way to do state management. It's terrible, okay? It's putting the state on the global element, which means that anything at any time could change it, especially since we use such a general name of state. Let's go make that a little bit better. And we do that by using a closure. I've talked about closures in previous videos, but a closure is a function that returns other functions or other ways to manipulate the data inside of the first function. Okay, so we have that function. Let's call it counter state, just like this. And down in here, we have some stuff. Now, we need a start. Okay, that start can be anything, but it should be there. We're also going to use min and max at some point, just like this. Let state equal start. Remember, we need to make sure that it's a number, so let's force it right now. Then we're going to return some functions. So maybe we use get count. Get count, and we set that equal to a method, or we create a method called get count, and we return state, because we won't be able to access state outside of this function. Okay, once this function is called, it goes away, but state sticks around because this needs it. Counter state itself is gone, but get count and the state being managed here still exist. That's the beauty of closures. So now we have set count, and for this one we're going to send it a number, and we're going to set state equal to that number. Let's make sure that it's proper here. And this is good. Okay, we can start to use this. The problem is these names. I don't like these names at all. Here's what we're going to have as an example before we go forward. So if we want to update the count, as an example, the add, the increment, okay, we need to go set count. We're going to have to go counter.setCount is equal to counter.getCount plus 1. Feels very noisy, right? So this is another place where we can use tools that we already have access to, tools that the language gives us. One of those is called getters and setters. So right here we can add a space and just go like this. And now we get count and we set count. And so when we do this, it's going to look a little bit cleaner. We're going to go counter.count equals counter.count plus 1. Plus 1. And the way that this works is if there's an equals, if there's an assignment, then whatever is over here gets passed in as the number. And it uses the set. If there is no equals, for instance, this one right here is not an assignment, it's a call, then we use the get and we just return state. So this will return state plus 1, and then the assignment will feed it into the setter count with that number, and it will update. Okay, so it's a little bit nicer to look at and just a little bit easier to use, honestly. We go down here, we're going to set const counter equal to, what did I call it? Counter state. Thank you. Too much talking, making me forget my stuff. In here we have the input.value like this, and the minimum, which I'm just going to type as this and this. Those should actually be a better variable, but for the moment, we have that. Now we can do that. So counter.count equals counter.count plus 1, and then just counter.count. Grab this whole thing. Thank you, 555, huh? Minus 1. And down here, so counter.count is equal to input.value. Let's make sure that that 2 is a number, even though I force it to be up here. See, right there. So we're just going to double check that. This should go away. And now everything should work the same, I hope. Let's check. Ooh. Yes, it does. Okay. What we don't have is the control for the buttons. So that's where these error messages come in. But we can do that too, okay? So over here, just like this, we can go and add in some conditionals. If these conditionals are true, then we are just going to return early, which means that we do not update the state, okay? Return early, don't update state, okay? So what is the conditional then? We need this, and this is going to use our minimum and maximum. Now, we need it to be truthy. If we set minimum to 0 or maximum to 0, 0 is a falsy condition. So we can't just test to see if these exist. We need a better test. And the way that we do that, we're going to do this twice. So I'm just going to fill those in. The way that we do that is by checking the type of, okay? Type of max, let's start with max, equals number, and let me try to remember, forgetting stuff. Num is greater than max, okay? So if max is a number and not just a falsy value, and the number is greater than max, then exit early. Same thing over here. Grabbing this, pasting it here. Or if min is a number and number is less than min, then return early, okay? It's throwing up. What is it doing? Oh, it's not an assignment. It is an equality check. So there we go. Now, when we use our plus button, it stops at 10. When we use our minus button, it stops at 0. We can still enter a really big number. It still stops us in the input, but at the very least, it gives us that warning. And then as soon as we change it, we get that beauty. So at this point, we have a really solid bit of code here that allows us to operate this input. We can operate it using arrow keys with the plus and minus buttons. We can also do direct entry in there. And when it's funky, or when it's out of range, we get some really nice error messages. They don't quite wrap properly, but that's a problem for another day. At this point, the only thing left to do is a performance optimization. And what I mean by that is right now we have this counter. And every time we start this counter, if we had another one or if we had 100 of these, counter state equals something, then it would put this getter and this setter into memory every time. So if we had 100 of these, there would be 100 get counts and 100 set counts. They wouldn't necessarily block each other, but it would be hogging up a lot of memory. So as a performance optimization, we can attach these, instead of putting them here, we put them on something called the prototype chain. The easiest way to get to the prototype chain is with a class. So instead of all of this, we can quickly defer to a class, capital letter, counter state. And in here we need a constructor. Just like this, it's going to grab all of this good stuff. So right here, and this, this dot state equals start, and this dot min equals min, this dot max equals max. Good. From here we can grab our methods, which are all of these, just like this, copy, paste them right down here. They don't go in the constructor because they are their own thing. They're methods on the class now, okay? Now we need to change some of this. This doesn't work. It needs to be this.state, okay? Down here, right here, right here, right here, right here, this.min, this.max, return early, this.state, okay? And now we have all this good stuff, but now we are only creating these functions once. I have an error message. What is the error message? Oh, the comma. We definitely don't need that. It's no longer an object. Is there another one? What's going on here? Oh, it's because I'm calling something that no longer exists. So, right, why is it jumping around? Right here, we comment this out. And now const counter equals counter state, new counter state with all of this stuff. Copy, paste right here. If this works, whereby if, I mean it totally works, okay? So now that this works, we have a better optimized system. We're only ever going to see these two methods in memory once, if we could do that. So a quick recap of what we've done. We started with some global memory. Global memory is the worst. So we went to a closure pattern, which allowed us to update state that is scoped inside of this function. And then finally, we went to a class-based system, which allowed us to attach things to the prototype chain and limit the amount of memory that we are otherwise hogging, okay? On top of that, we added some error states, and we did it in a really cool way, I think, right? We allowed the browser to do that work for us. We didn't have to add a whole error handling logic system because the browser already gives us that for free. And the more that we can lean on the browser, the easier it is for us, right? So we didn't have to do that. We just had to use it, okay? We also optimized a little bit by adding what is basically a render function and did some cleanup. So that's it. That is the number input. And there are at least 3 ways to do this that you've seen: global, closure, something else, class, lots of different options. But I really like this class-based system because it just keeps it nice and clean and shows a higher awareness of how browsers work, how memory works, how JavaScript works. If you have questions, please let me know, and I will see you later.